And let's take a look at a couple more examples, getting this a little bit more difficult. I want to find the antiderivative of this. Well, to do that, I'm going to rewrite this thing. I'm going to write this as the integral of 2x over the square root of x plus 3 over the square root of x dx. See, I can break that up like that. Well, that's going to make it a little bit easier because just a little bit of algebra here. This is the integral of 2 times the square root of x plus 3 times, or 3 over the square root of x dx. And so I'm going to rewrite this one more time, and I'm going to use fractional exponents. So I'm going to write this as the antiderivative of 2x to the 1/2 plus 3 times x to the negative 1/2 dx. See, now it's set up in a nice form that I can do what I've been doing in the other examples. So this piece right here, when I take the antiderivative, I'm going to take 2x to the 1/2 plus 1 divided by 1/2 plus 1 plus 3x to the negative 1/2 plus 1 divided by negative 1/2 plus 1 plus c. Well, this is going to be equal to, I guess I should do that. That's where that piece came from. See, this is going to be equal to 2x to the 3/2 over 3/2 plus 3x to the 1/2 over 1/2 plus c. But I doubt you're going to leave it like that. You would write this as 4x to the 3/2 over 3 plus 6x to the 1/2 plus c. Now again, if I took the derivative of this, see, I think I have room right here. So if I take the derivative of this, let me erase that, d dx, I'll get 3/2 times 4/3 x to the 3/2 minus 1 plus 1/2 times 6x to the 1/2 minus 1 plus 0. The 0 is for that c. See, the 3 is going to cancel. 2 cancel with a 4 and give me 2. So this is going to be 2x to the 3/2 minus 1 is 1/2 plus the 2 is going to cancel with the 6 and give me 3. And this is going to be 3 times x to the 1/2 minus 1 is negative 1/2, which is exactly what we started out with. Well, actually, we started out with this, but we did some modification to get it into a form that we could work with. So let's take a look at another trig function here. I have sine x over cosine squared of x. I'm going to write this as being the integral of sine x over cosine x times 1 over cosine of x dx. That is equal to the integral of, this is tangent, times, this is 1 over cosine is better known as secant of x dx. So now I'm looking at this going, okay, what, the derivative of what will give me tangent times secant? Oh, that's secant plus c. Derivative of secant is secant times tangent, which is the same as tangent times secant. So if I take the derivative of this, d dx of secant of x plus c, that equals secant x tangent x plus 0, which is obviously my secant x tangent x is right there. So a lot of these finding antiderivative stuff is just simply a matter of looking at the function, saying, okay, what derivative would, or what function, when I take its derivative, would give me that answer. We're going to spend the next several weeks working on different types of techniques to help make it easier in certain situations. And you start recognizing different patterns, but really that's basically it. If you're dealing with a polynomial, add 1 to the exponent, divide by the new exponent. If we're dealing with a trig function, then right now we need to think in terms of what trig function, if I would have taken the derivative of it, would give me what I have in the integrand.